we'll get through unit N. Okay, so we will get all the way through unit N. Okay, next trimester we have a couple short units, so we get through a couple more. All right, so unit I is all about types of functions. In I-1 today, we're going to talk about identifying functions. So everyone should have out their notebooks. Mohammed, notebook, please. Take out your notebook, dude. You need a paper?
Huh?
Line paper? There you go. All right, Aubrey, please move to your chair, please. Thank you. I got you. Thank you.
It tastes like sounds good. We're gonna start already.
Yeah, no, but yep, I think I saw it. All right. Aubrey, you can pull up next to Ruby there on the table. At your actual spot.
Okay.
Thanks. All right. So first off, we need to go over our definition of a function. That's what we're going to be working with today. So function, you need a pencil? Here you go. You can have mine. A function is a relationship. And in math, our relationships go between our x's and our y's. So it's a relationship such that every input, which in math our inputs are, so every x, every input, has exactly one output. And our outputs are the y's. All right, now in the real world, when we do certain things, when we have an input behavior or an input idea, we need to know, for example, if you come to class 2 minutes late, that's your behavior, that's what you did, what's going to happen based on coming to class 2 minutes late? You have a tardy. Does that mean you're going to be counted absent? No. If you come to class 2 minutes late, does that mean you're going to get sent home? No, but you can expect when you get a tardy, when you come late, what's going to happen? You get a tardy, okay? If the output is making Miss Morrell annoyed. You guys are real good at this. Just kidding. What's one way to make Miss Morrell annoyed? Talking back, okay? If you talk back to Miss Morrell's going to be annoyed. Is that the only way to get the output of Miss Morrell is annoyed? No. What's another way to annoy Miss Morrell? Being loud, all those good things. Chewing with your mouth open, number one. Okay? If you chew with your mouth open, you know there's other ways to have that happen. The big thing is you want to know for the behavior you're doing, what's the output going to be? What is that outcome? So right now, if you're taking notes... Oh boy.
I'm sorry, I'm falling apart over you.
Alright, if we're taking notes, what's your output? What's going to be the remembering it more, having notes, Miss Morrell's happy, better on the test, all that good stuff. Alright, we're going to split our paper into two. So you can draw a line all the way down the front part of your paper. I went all the way to the bottom. And we're going to do a non-example. What does it mean to do a non-example?
Something that's not right.
Yep, something that's not right. And what's kind of goofy about identifying to see if there's anything wrong. And then if there's nothing wrong, then we say, yep, it's a function. It works because there's nothing wrong with it. Okay? But if there's something wrong with it, then we're like, yeah, that function, it doesn't work. All right, so first we're going to do a set of ordered pairs. And remember, ordered pairs look like what? They don't look like my mom. A set of ordered pairs, we have that parenthesis, x, and then y parenthesis. Okay, and because we're doing a set of them, we want to group them together. And since we're already using parentheses, Abdiziz, put your phone away. Since we're already using parentheses, we're going to use these fancy brackets, these kind of squigglies. It took me a really long time to really perfect that squiggly bracket, which to you probably just looks like a squiggle. But it looks really good, you guys. All right, so for my first ordered pair, I have 3, 5, 2, negative 4, negative 4, negative 1, 3, 0, negative 2, and 3, 5. I'm going to do a little squiggle there to show that that is the set. That's what goes together. This, when I look at my x's, what I want to know is if all my x's have exactly one y. So when I put in a 2, my y, is there any other ordered pairs where when I put 2 in, I get something else?
No.
Or if I put in negative 4, what must I get out?
5.
A 5. If I put in negative 1, what must I get out?
3.
3. When I put in 0, I get out. Okay, what about this one though? Because I put 3 in, and what must I get out for a 3?
5.
Well, here when I put in a 3, what do I get out? A 5. Is that okay that it repeats? Yeah, as long as I get the same number out. Okay? Alright, so for my non-example, again I'm going to do that little squiggly for my bracket. I have 3, 6, 4, negative 4, 0, 3, 2, 6, negative 2, 0, yeah, you can set that there, and then 4, negative 1. Alright, so my goal, I want to know exactly what I get out for my y. So when I put in 3, I want to make sure that the only, is there anywhere else in this relationship where I put 3 in and I get something else out?
No.
Nope. Can anyone find which point or points make this not a function?
4. Negative 4 and 4,
Negative 1. What makes that not the function then? 4. This time when I put in 4, I get out negative 1. Because if I have the same x, but different y's, it won't work. So I'm going to like box this and like cross it out, saying it doesn't work. But I want to be able to read that so that I can see what doesn't work. X, different y, does not work. So when you look at it as ordered pairs, remember those x's are the numbers that come first, and you're comparing those x's, seeing if there's any repeats of our x's that come out to different y's. Here we had 2 4s that repeated, they had different y's, so it's not a function. Here we had x's, we had 3 repeated, they have the same output, they both go to 5. Alright, so now we're going to do this as tables, just to view it as a table, see how it looks. Y table. And we're just throwing in these ordered pairs so we can look at our x's and our y's. It's just organized a bit different. We just want to compare it with our to expect. So our first one here we have 3, 5. So 3. And then we'll have 2, negative 4. Then negative 4, 5. This is 1.
Sounds good. Thanks.
Alright, 3, 5. What was our next one? Sorry. 2, negative 4. Negative 4, 5. Negative 1, 3. 0, negative 2. And then our last one was 3, 5. So in this case, it's a little bit easier to identify our x's because they're all lined up. And we're seeing, is there any repeats in that x column? And we see there is a repeat. It's the 3. So this is just a repeat, and a repeat is okay. A little smiley face saying, yep, a repeat is okay. Now, if I look at my y's, do I have any y's that repeat?
Yeah.
Yeah, which y's repeat?
3.
Yeah, there's 3 5s. Do all those 5s have the same x? No. But does that matter that our y's have to have only one x? No, our rule is that each x has to have one y. Those y's can happen as often as they want as long as every x has one y, which in this case it does. And we're just copying these points down from the top. So we have 3, 4, negative 4. Oh, daisies. Dude. Do you need me to take it or what? 0, 3. 2, 6. Negative 2, 0. And 4, negative 1. So again here, what is our issue? Where do we function does not work? We're going to look at the x's and see, are there any repeating x's? The 4's go to the same thing or different things? Different. So because this 4, I get a negative 4. This 4, I get a negative 1. This makes it not a function, hence why it's underneath a non-example. Because that negative 4 is different from that negative 1, doesn't work. Okay, doesn't matter any of the other numbers that are repeating, like this 0 and 0. I have 1 0 that's an input, 1 0 that's an output. That's totally fine. These 6's and the y's, that's okay. The problem is that I have these 4's together in these x's, and it's coming out of it. All right, what's going to happen next is you are going to get 2 graphs. You move it. And if you have space on this page, you're going to glue them in on this page. If you do not have space, that's okay. Just glue them in on the next page. Okay, so I'm going to glue in my graphs right underneath, right here and here. So if you have that space, go ahead and glue them in there. You might need to trim them a bit. Please make sure you're being careful of your scraps, because my room is already super messy. No, okay. Alright, so go ahead and get those put in, maybe trim them down a little bit. If you have space on the bottom of this page, get them glued in on this page. If you don't have space on this page, glue them in on the next page, but maybe rewrite which one is the example and which one's the non-example. Whoa. Do you have a pass, dude? What? No? Okay. We're right in the middle of the notes, so why don't you take out your notebook. Okay, so get those two glued in. So again, kind of the idea of what we're doing today, it's a little goofy, is that you're seeing, like, if there's, you can find something that's wrong with it. There should be some in there. Yeah. Oh, you need the graphs? Sorry. Then it's not a function. But if you can't find a problem with it, then it works. Alright, so for this first one here, we're going to just plot these points. And the second one, we're going to plot these points. So if you want to work ahead, you can. If you're feeling a little bored, you're waiting for everyone else to get caught up, go ahead and plot your points. Double check as you go. Okay, if you had to glue these in on the next page, you might want to write example on this one, because this one's the good one. And this one is the non-example. This is the bad one. So if you need to write that as a reminder, especially if you're on the next page. Any graphs? Oh, you okay? Alright, we have 3, 5. So for 3, 5, from my origin, from that middle, how am I going to get to 3, 5? Right 3. Up 5. Beautiful. Thanks, Ruby. Who can tell me how to get to 2, negative 4? Right 2, down 4. Ruby's on a roll. Somebody else got it? Negative 4, 5. Left 4, up 5. Perfect. Left 1, up 3. Alright, here's the tricky one. 0, negative 2. For 0, negative 2, are we going to go up, down, left, or right for 0, negative 2? Down. Good. I don't go left or right. We just go down 2. And then I have 3, 5. So right 3, and then up 5. But we already have a point there, and that's okay. Okay? So this one's a good graph. Now let's do the one that's not so good graph. We have 3, 6. So from our origin, we're going to go right 3, up 6, which is at the very top. 4, negative 4. So right 4, down 4. All right, 0, 3. That one's a challenging one. Is 0, 3 going to be right? How did you know it was going to be up 3? So right 3, because right is also positive. What told me to go up? It's on the y. Good. 2, 6. So right 2, up 6, way at the top again. All right, negative 2, 0. Left, right, up, or down? 2. And then 4, negative 1. So right 4, down 1. This graph, which one is the problems? We already identified the problems before. The 4s. So this 4, negative 1, and 4, negative 4. What's the relationship between those 2 points on the graph? Yeah, and on the same x means they kind of line up in which direction? Yeah, they line up vertically. If I look up and down, they share an x. They share that vertical. So that's a problem. Is it okay that these two share a y, that they line up this way? Or side to side? Yep, that's okay. Remember, it's okay if they have the same y. What can't they have? The same x. So that's a problem. And that actually brings us to our last idea. I know these notes, for some reason, feel really, really long. I don't know why. My other classes, it felt like it went by faster. Alright, is that this vertical. So that brings us to our last idea. It's the vertical line test. Okay, and vertical means up and down. You need to write that in there so you remember vertical is up and down. vertical line test. All right, and again, this is a way for us to check to see if there's something wrong. If it's wrong, it's not a function. If it's right, or if there's nothing wrong with it, then it, okay? Do any of you guys ever feel that way with like your parents where like they're always looking for something wrong? If they see something wrong, then they tell you, yep, that's wrong. But if they don't see anything wrong, they don't like tell you. Sometimes I feel that way, where it's like, just tell me I'm doing things right. Functions are kind of the same way. You're always looking for something wrong, but then if there's nothing wrong, we're like, okay, it's fine. All right, so this one's a little bit longer of a definition. If you can draw a vertical line, which again, if you need to remind yourself what a vertical line is, you can draw that in there, that touches two or more points, then the graph is not a function. I know that was kind of a lot to write, so I'll give you some time to write that down. If you can draw a vertical line that touches two or more points, then the graph is not a function. We have this, we don't need to cut it apart this time. If you do cut it apart, that's fine, just glue them in separately, I guess. You just don't have to. Okay, so finish writing that down, and then get that glue in. Oh my gosh, Miss Merrill, there's a heart. That's so cute. You guys cute. You know why I did a heart? No, it's Valentine's Day. And I love each of you so much. I know I made it sound like that was sarcasm, but it wasn't. It's true. Aubrey, what are you doing? Did you get an email from me today? Yeah. But it's not for you. I know, I was just about to. Yeah. I got you and another person. Alright, so go ahead and get that glued in. We're going to this will take like 2 more seconds and then we're done. So finish your definition of vertical line test. And glue that in right underneath it. I'm going to use 2 colored pencils this time because the highlighter just isn't exact for me. So I'm going to use just green and orange because orange shows up nicely. So if you'd like to take out green and orange, you can. If you want to just be boring and not use colors, that's okay too, but I think that's boring and I find it really hard to remember what we did here. I'd for sure at least grab one color. We didn't cut it, no, we just glued it in. Yep, just glued it in. I can check Skyward. I don't think I have marked. I think he's just gone today. Yeah, he was marked sick today. Yeah. Alright, so here we go. I'm going to draw some vertical lines here. So here I'm going to draw my first vertical line. How many times does that touch my graph? Once, right here. When I say talking about this curved line, it touches it one time. So I want to think, if I continued to draw vertical lines, no matter where they are, if I draw, are there any lines that would touch my graph more than one time? Can anyone think, could I draw a line that would touch that graph more than once?
If it was vertical,
Okay, but I have to draw a vertical line. Is there anywhere on this graph where it would touch it more than once? On this curve? Even if I draw it down here, what's happening over there? It's still only one time. So as long as my vertical lines only touch it once, it is a function. It works. Alright, now because of it's Valentine's Day, and I wanted to remind you all that you all have... Alright, if I draw a vertical line on this one, with that vertical line, how many times does it touch the graph? Once. So does that mean it's a function? Is there somewhere else I could draw a vertical line that would touch the graph more than once? At the positive 2? At positive 2 right here, how many times does that touch the graph? It touches it once up here at the top, and then kind of here and a little bit at the bottom there too. It touches it almost 3 times. I can also draw one a little bit closer to the edge there that will show it a little bit more. So as soon as I know that I can draw a line that touches that graph more than once, what do I know? There's a problem and there's nothing we can do to fix it. It's so sad. It's just not a function. Which is okay. There are places in our lives where not a function is good. Where sometimes we don't want to know the exact outcome of something that we do. Sometimes we want to test around with it. Okay? So, not a function is okay. It's not something that's wrong with it. It's just the classification. Okay? Alright, that is it for your